This is section 3.3 part 2, where we are going to look at graphing a system of linear inequalities with no solution. So we've got our system of linear inequalities here. Alright, so the first step is going to be to graph each inequality. So I've got y is greater than x plus 2. So this is my y-intercept, so I'm going to plot a point at y equals 2. Then my slope is 1, which is just like 1 over 1. So from this point, I'm going to go up 1, right 1, or from this point, I could go down 1, left 1. I'm going to connect the points with a nice straight dashed line, right? It's only greater than, it's not greater than or equal to. Alright, so I have to use a dashed line. If we saw greater than or equal to, that equal to would mean it would be a solid line. Okay. Next, let's graph the second equation, which is y is less than or equal to x plus 1. So this tells me I'm going to have a solid line. So I'm going to plot a point at y equals 1. My slope is again 1, which is 1 over 1. So I could go up 1, right 1, plot a point, or I could go down 1, left 1, and plot a point. So I'm going to draw a nice line here, solid this time, passing through my points. And you probably see that they're parallel. And if your mind is going back to, oh, parallel lines, we did this with equations. There's no point of intersection, so there's automatically no solution. That is true when you have parallel lines for equations. Just because the two inequalities are parallel doesn't automatically mean there's no solution. You still have to shade. All right, because remember, the solution will be where the shading overlaps. So the only time you can have no solution is meaning the shading will not overlap at all. So we want to make sure that that happens. So I'm going to do some work down here for my test points. So I'm going to use the first inequality, which is y is greater than x plus 2. My favorite test point of 0, 0 I can use because it does not fall on this line right here. So my test point is 0, 0. So I'm going to plug in the value of y, which is 0, and the value of x, which is 0, and I'll simplify. So I've got 0 is greater than 2. Is 0 greater than 2? No, well, that's false. So what happens when you have a false inequality, a false statement? Well, you are going to shade away from your test point. In the previous problem, we got true solutions when we tested our test point, and we saw we shaded toward our test point. So when you get a false solution here, you want to shade away. So 0, 0 is here. I'm working with this line. I want to make sure I shade all areas that do not include my test point. So I've shaded in the opposite direction, away. Now I've got to look at the shading for the second inequality. Y is less than or equal to x plus 1. So I'm going to come down to y is less than or equal to x plus 1. My favorite test point still can be used. So my test point is 0, 0. And I'm going to plug in 0 for y and 0 for x. Simplify, and I see 0 is less than or equal to 1, which is true. So if it is true, you want to shade the region towards the test point. So in this scenario, that's in this direction. So what do you notice about the shading? One got shaded in this direction, the other was shaded in this direction. Do we have any overlap? No, we don't. Alright, so our answer is no solution. Alright, because there is no overlap in the shading.